Vaibhav, and thank you, Sammy, for organizing this. I am super excited to be presenting on this topic today. Again, my name is Sudhir. I work for a company called Avanade. Avanade is a joint venture between Microsoft and Accenture. We are a services integration. We're focused on consulting, and we work on and only one platform, that being Microsoft and Azure. My role, I'm the senior director for AI for Midwest. It essentially means I'm responsible for all of our AI projects and our AI business in the Midwest. And I get involved with solution offerings, coming up with different types of mechanisms we can interact with our customers from an AI perspective, coming up with use cases, solutioning, and then passing it on to delivery. So then I can work with them to make sure we are successfully delivering AI projects. With that, I'm going to change my setup over here real quick. So give me just a fraction of a second. I'm going to turn my camera off. I'm going to switch to my other monitor, and I will bring up my deck here shortly. So just give me like about 10 seconds to do that, please.
And I want to take those 10 seconds to inform everyone that our sponsor is also gonna give away 2 Amazon gift cards at the end of this presentation. So hang on there at the end. After Sudhir ends his presentation, we are gonna have a draw. I've taken a list from the Meetup RSVPs, and we are gonna pick up 2 winners out of it.
All right, you guys can still hear me, right?
Yes.
Okay, very good. So with that, here is my deck. And I am assuming everybody can see my screen as well.
Yes.
Okay, so the goal for today is to talk a little bit about AI. And as the meeting introduction said on our website, I'm not going to get into any deep technical things about AI, right? Such as, AI modeling or machine learning or any of the algorithms in machine learning, stuff like that. That's not the intent of this presentation. The intent of this presentation is to kind of get some very basic concepts out of AI, out of the way for AI. And then what I really want to do is sort of kind of talk about enterprise AI. And the reason I'm very passionate about this topic is when I talk to customers, I see most of the customers doing what is called as use case oriented AI. Like they have a particular problem and they potentially think or may use AI to solve that problem. And that is okay. There's nothing wrong in that approach. However, I do think that's not a very complete and sufficient approach. So really the goal of this presentation is to talk about what is AI really at an enterprise level. What is an AI-enabled enterprise? What is really an AI enterprise framework look like? What's the methodology? What's the process? Some things with data preparation, so on and so forth. And then, of course, since this is an Azure user group, I'm going to talk about AI on Azure in terms of what are some of the platforms, tools, capabilities available. I'll show you some of the architectures that we have worked on. I'll talk a little bit about cognitive services. And then we'll get into some AI case studies that my company has delivered so far to customers. I'm sure you'll find that interesting. So that's the agenda. So with that, let me talk a little bit about the very basic definition of AI, right? It's always a good thing to start sort of kind of from first principles. So the basic definition of AI is the ability of a computer system to perform tasks that normally require human intelligence. Well, what would that be? Visual perception, right? The ability to look at something, maybe an object, and say, that's a dog or that's a cat. To do speech recognition, which may involve speech to text translation or may involve translation from one language to the other. Decision making. We can think of this as the next best action. You may look at potentially what your customer has bought in the past and make a decision to recommend something, right? Translation between languages, as we already discussed. So the next question is, well, what is AI capable of doing as things stand today? So this is what I will say, right? Generally speaking, what they say is AI can do the following. Any observation that a human can make in about 1 second or less, most likely you can figure out a way to kind of have those sort of kind of cognitive abilities using AI. What does an observation in about 1 second or less look like, such as quickly detecting an object or a shape, things of that nature, right? Of course, exceptions exist, but generally speaking, you can think of, the capability where AI is today. If it takes you about a second or less to make some sort of determination, observation, potentially even conclusion, that's possibly something that we can solve using AI. Predictions based on past and historical data, well, that's probably one of the most obvious use cases. And then data clustering for marketing and segmentation. Now, one of the most important sort of techniques, so there's basically two types of techniques that is used in artificial intelligence. One is called as the supervised learning, and the other one is called as unsupervised learning at a high level. Supervised learning is the one which is being used today for a variety of reasons from a real and practical AI solutions perspective. So I say over here roughly 80 to 90%, sometimes I've even heard as high as 95 to 99% of the problems today, if you solve it using AI, you're most likely going to solve it using a technique called as supervised learning. Supervised learning simply means you're essentially creating A to B mappings, and I'll show you here in a minute what those look like. And the other key thing for that is you need tremendous amount of training data for supervised learning, and I'll talk about what training data really entails and what all that is about. So what is supervised learning? Right, supervised learning basically means, and I think there's a cat or a dog mentioned on my screen, so my dog got a little excited about that. Sorry about that. What supervised learning essentially means is we are creating input-output pairs. So, and this part is called as training the model, where we show the model or actually teach the model as to what the input looks like. And if this is the input, then this is what the label for that input is. So for example, if you want to come up with a detection system for detecting, say, dogs, say you're having a problem in your backyard and you want to create a computer vision based system where you have a camera and the camera is taking pictures or it's having a video feed. And in that video feed, you want to analyze the image of a dog, let's just say. You would then train the algorithm by feeding it literally hundreds or potentially even thousands of images of a dog in a variety of different shapes, small dogs, big dogs, medium dogs, through a variety of different angles, running, lying down, sitting, so on and so forth. And then the algorithm is trained, and that's what essentially is supervised learning, right? The same example, say like for email, you essentially come up with email pairs of spam or no spam, train the model, and you get into what is again called as supervised learning. The same thing with translation from one language to the other, web ads, the propensity to click on a particular ad, so on and so forth. So this is a very, very important and key technique in AI today, again called as supervised learning. Now, I'm not going to get into the theoretical aspects of supervised learning, unsupervised learning, so on and so forth. But the important thing to remember over here is supervised learning today, as it stands in the AI world, is the predominant technique, the high-level algorithm, so to say, which is used to solve a lot of practical AI problems. And the other key takeaway from this is supervised learning requires a lot of training data. So more training data you can create or generate, you're always going to be better off from an accuracy of the model prediction perspective, so on and so forth. The big difference between AI, now that we're on the topic of supervised learning or we're on the topic of algorithms, the big difference between AI and traditional programming is as follows. In AI, we tell the computer what we want. The computer then learns to figure it out by using some algorithm, maybe linear regression or whatever, right? So think of that for a minute, and I want to make sure that we understand that very well. In traditional programming, if I had to figure out a dog, my God, I'll have to write a program that says, if face dimensions are so and so, and if the body size is so and so, and then come up with these nested if then else loops, and then maybe I might be able to describe a dog. And most likely, I'm still not going to be accurate because the combinations and the permutations are so high that it's not going to be correct. I'm not using that if then else programming technique anymore. I'm not using instructions given to the computer to identify a dog. What I'm doing over here is I have come up with some sort of algorithm which basically tries to figure out, using training data, what a dog looks like, and quote unquote, gain that intelligence. And then once I move from my training data to my test set, anytime I give it a new picture, it has now gained that ability to basically look at the picture and say, oh, this looks like a dog to me. And when it says that, it gives a confidence score that I'm about 95% confident this looks like a dog, or a 99% confident this looks like a dog. So that's a key point. A very, very important thing to kind of understand that. Okay, quick pause. Any questions, Vaibhav, so far?
No, I think we are all good.
Okay, very good. So moving right along, why AI, right? What is the business significance? This is a very strong message from my side. I totally believe in this, and this is something kind of important that our enterprises and our executives and leaders understand this, right? That 75% of executives say their companies might simply go out of business in the next 5 years if they are unable to scale AI. Survey of 200 CIOs say that 80% of the CIOs will boost use of AI and machine learning in the next 12 months. And then in another survey, executives across industries said AI will be critical to their company's near-term success. So this is real. This is real technology. I'm not talking about something in the future. This is another reference from McKinsey survey, which is important to understand, right? There's $13 trillion of value, economic activity to be generated by 2030. So my advice to you is, if you're not doing AI and doing something else, I would definitely start looking at this. If there is so much potential out there, and again, 2030 is just merely 10 years out, imagine the amount of opportunity in this field. What they also say is late adopters might find it difficult to generate impact from AI because the front runners have already captured AI opportunities, and late adopters will lag in developing the capabilities and attracting talent. And of course, talent is a big problem in AI. It really is. So the time to act is now. We have to jump on this. And again, as I said, there's nothing futuristic about it, right? It's possible today. I have customers who are actually implemented solutions using some very clever AI techniques. The other thing is AI is the new electricity. It really is, right? So if you kind of think of electricity and what it was, I don't even know how many years ago, 50, 60, or potentially 100 years ago, when electricity was not as common as it is today. If only a few companies at that time had electricity and nobody else had, think of the competitive advantage they had, right? So it's very powerful. It's a true game changer. It can impact your bottom line as well as your top line. And the other point I want to make is, one of my biggest disappointments today when I talk to customers is, as I said earlier, they think of AI as a singular project. Oh, I have about 200K budget. I want to put this system in, which kind of recognizes some objects in my factory floor. And if a certain object is not there, then it needs to trigger something, and I have 200K for that. Well, that's good. We are happy to work on that. But the key thing over here is, companies have to give it ERP-like significance. In other words, you have to have the right kind of enterprise-wide thinking. It has to be well-funded. They have to think of this more as a mission-critical thing than as a one-off project. Okay, so then the question becomes, what's such a big deal about AI? Why is it happening now, right? I mean, some of the algorithms that which AI is based on are very, very old mathematical and statistical concepts, which have been around in some cases for like decades, sometimes even 50, 60 years. Well, if you observe, in the last about 5 to 8 years, maybe even 10 years, our industry has changed significantly. Three key enabling forces, right? One is computing speed, Moore's law, that keeps increasing. Computers are becoming more and more powerful. Along with compute, storage is becoming unbelievably cheaper. Then there is an explosive growth in the amount of availability of data. Just all types of data. I mean, I one of my favorite examples is in one of the national parks in Africa. They wanted to identify how many, I think giraffes, how many giraffes are in the park. So they simply went to the internet and from open source, publicly available sources, downloaded all the possible images of giraffes that were taken and uploaded for public consumption. And they could get literally thousands of those images, come up with a supervised learning model, and train an AI model to identify giraffes, right? So that's an example of how much data is out there and available. And of course, cloud computing, right? You guys, most of you probably use Azure already. The capabilities of the cloud of Azure are huge. If you want to set up a quick AI experiment, if you want to spin up a Hadoop cluster or a database cluster, it is very easy to do it for companies and as well as for individuals for experimentation and learning. So when all these forces have come together, it has sort of kind of created a force which has made now AI all of a sudden possible. And again, don't forget data. We have tremendous amount of data out there, structured as well as unstructured, which now makes AI possible. And the data is accessible. We can store it. We can do all kinds of interesting things with it, so on and so forth. All right. Let's move on to the topic of what is an AI-enabled enterprise? Well, why am I so passionate about enterprise level AI thinking and what it really is? Vaibhav, quick check. Any questions so far?
I don't see any. I think we are all good so far.
All right. Well, it's a quiet audience today, huh? Either my message is resonating or people are like, wow, I don't know what he's talking about. Okay, anyway, so let's get into this topic of what is a AI-enabled enterprise. And the way I kind of like to explain it is by giving you a few examples, right? So kind of go back maybe 10, 15 years when once in a while we had to jump into a taxi and go from one place to the other. So if you look at a traditional taxi company, they have all the traditional business processes, the way they run their business, the way they coordinate different taxis and different drivers and routes and all that kind of stuff. And then when the internet came on, I'm sure they built a website. Eventually, they also built an app. But I do not consider a traditional taxi company who has traditional business processes and then a website and then an app. I don't think of them as a data or an AI enabled company. Now contrast that with like a Uber or a Lyft, right? The way Uber or Lyft is built from ground up, it is built completely as a data and AI oriented company. For a taxi company, the actual vehicle is basically their key asset. But for an Uber or a Lyft, for a rideshare company, their actual asset is their platform and the data around that platform, right? You see the difference? And that is the key difference. And these companies are born as data or AI enabled companies. So for a traditional company to become a AI enabled company, right? So if you are say like a maybe whatever, a Conagra or a UP or a Kiewit, you're what I call as a traditional company. And for those types of companies to become AI enabled, few things need to happen. One is there has to be a top to bottom AI awareness and buy-in that this is important for us and we want to do this. There has to be a unified data warehouse, at least some effort around that, because again, as I said, data is absolutely important. They have to revisit the workflows and figure out opportunities to take those business workflows, and I have some examples later on about what a business workflow is, to see where you can AI enable it. Ideally, also a centralized AI team and willing to risk AI adoption. And that's when these types of traditional companies have the opportunity to become an AI enabled company. Having said that, this is some key points that I want to make about, what would be a good example of an AI-enabled enterprise, right? And of course, any company, any traditional company can sort of recreate itself if the management really thinks this is worthwhile to become AI-enabled. One is there has to be AI awareness in all levels, right? Starting from the C-suite, middle-level managers, everyone else involved, business and technical, and across the board training as relevant to your level as possible, right? There are tons of stuff on Coursera everywhere that literally anybody can take. If you're a business analyst, you can take courses that are relevant to you from an AI perspective. So you understand what this is all about, what the technology is all about, what can you do. If you're a technical person, if you have interest in this, and if you identify a particular, maybe like data engineering, let's just say, there's definitely opportunities to learn there. Then there has to be a business process enablement, right? A framework to examine your business processes currently across all different business units, right? Across HR, across finance, across manufacturing, or whatever you may have. AI-based business process thinking. That this is a traditional workflow which we have been doing. How can I take that workflow and how can I now insert or inject some AI magic in it? And then the ability to create best practices and reusable patterns. From a technical perspective, I would recommend you need an AI leader at a high level. You need to have technical teams which are trained in AI and different aspects of the AI, right from data engineering to machine learning, so on and so forth. You need data enablement, which may essentially mean a unified data warehouse, ability to have data accumulated, aggregated, so on and so forth. This AI team has to be cross-functional. In other words, I recommend a centralized AI team, but it has to have essentially reach out in all different business units, all different types of business initiatives going on, so on and so forth. And again, the ability to create best practices and reusable pattern, which is very, very important. All right. Now that we're done with the definition of the AI-enabled enterprise, I'm going to get into an enterprise AI framework. So if you have to create an AI-enabled enterprise, and if you want to take on AI projects at an enterprise level, what does that framework look like, right? So I'm going to spend some time going over that.
So
Any
sorry to,
questions,
yeah,
Mehmet, for us?
I wanted to tell you there is a question. Are clients you have seen comfortable with black box solutions, or are they more sophisticated and have resources that understand the math, statistics, and libraries? Jay Bynes has asked that question.
Yeah. So that's a good question. Let me summarize. Let me repeat it to make sure I've understood right. So I think the question is, what am I seeing with my customers today? Are customers buying, off-the-shelf black box type solutions, or are customers standing up teams with, specialized resources, data scientists, ML engineers, so on and so forth? Correct. So here's my opinion about that. Right. Depending on who I talk to, the AI maturity of our customers significantly varies. Some customers are well ahead, some are just starting out. And at the same time, there are tons of players out there who have specific solutions or specific tools for AI. Like, for example, there are companies who specialize in AI just in speech translation or speech to text, so on and so forth. Then there are companies who specialize just in computer vision. They have different types of applications with computer vision. Then there are generalist companies like myself who want to do AI at a very sort of kind of fundamental level, so to say, by creating, data platforms, data lakes, starting from there to Databricks to ML models, so on and so forth. And of course, not to say we also have a lot of repeatable assets and things of that nature. So honestly, the curve that I'm seeing or the maturity path I'm seeing varies. Now, if there is a solution, if you have a very specific problem for which a custom or for which a out of the shelf, out of the box solution exists, then I think a lot of customers are going to probably prefer that because it's easy to buy, easy to implement. But then again, as I said, that is just sort of kind of a solution to one particular problem, right? That is not the definition of a true AI enabled enterprise. That's a starting point, and I have no problems with that. So that's kind of what I'm seeing from an enterprise perspective. Anything else, Weber? Any other questions?
No, I think we are good. Does that answer? All right, I got a thumbs up, so we are good.
Okay, all right, very good. So again, now let's kind of talk about the framework, right, for AI at an enterprise level. So what does that look like? Well, first of all, you have to have a enterprise AI view, a much broader view, and again, kind of go away from thinking of AI as a particular solution to a particular problem. You have to have a much more broader AI vision and AI view, right? Let's start with that. Now, when I say that, the next statement I'm going to make is keep that vision, but start small. Your first project should be something which is manageable and easy to deliver and sort of kind of the low hanging fruit. As your very first project, you do not want to take something that is very complex and can not have a very good chance of succeeding. So start small, and deliver quickly, show ROI. Then create meta cases and reuse those. In other words, oh, I solved this problem using this type of particular AI pattern or AI algorithm. Now, how can I take this and reuse it somewhere else? And then always think of the data foundation. One thing that is going to really help you is this broader data foundation, because if you have this data repository and your data is not siloed and locked into 20 different systems, you can then leverage it in multiple different ways to come up with very powerful and effective AI models, right? So that is absolutely critical. Okay, so then the question becomes, well, how do I pick my first project? What's generally speaking a good idea for that, right? So the way I like to explain that is there is an intersection that you have to look at. Intersection between business value, a project which is of business value and significance, right? Otherwise, what's the point? Why would you do it? If you do an experiment that the business is not willing to even consider, then that's a complete waste. So it has to have some business significance, right? So you probably have about 50 projects, let's just say in this circle, which are of business significance on the right. On the left is the technical feasibility. And when I say technical feasibility, I purely mean from an AI perspective, how can AI solve that problem? And some problems are technically very easy to solve, but they are of no business value. And some problems are of tremendous business value, but from an AI perspective or from a technology perspective, they are very hard to implement. So you definitely don't want to kind of get into that. So pick this nice intersection of technical feasibility and as well as high impact or business value, right? So that's definitely what we recommend starting out. So be very smart about how you pick your first AI use case. We call it the lighthouse project, right? It's a lighthouse project. It's a high visibility project, but technically it's basically low risk. So definitely start with that. Now, one thing though, I do want to make sure that we all understand, and this is sort of kind of a mistake that customers make a lot of time, is they sort of kind of think that AI is this black box solution. It's almost like magic, that I have data and then I magically, or have, let's just forget data. Let's just say I have some business problem. And then magically I put this AI algorithm in the middle and then my problem is solved. It really doesn't work that way. There is a workflow that we have to follow, and there is subtasks that we have to understand and implement AI very carefully, right? So this is how you do it. So this is the workflow or the design to implement AI ML projects. What you have to do is you have to first identify the business problem, and of course make sure that the business problem is worth solving, right? In other words, it is worth spending your time and money. It's of high significance, so on and so forth. Then you have to figure out what are some of the workflows associated with that business problem, and I'll show you an example of a workflow. What I really mean by that here in a minute. within that workflow, figure out, can traditional programming solve it, right? If traditional simple techniques, which have been well known and well established, and you have a team who does it, can do it, by all means. You don't have to use AI, but most likely you're considering that problem because traditional programming cannot solve it. Then let's get into exploring the AI, the ML model, right? Is it a prediction model? Is it pattern recognition? Is it data segmentation? Computer vision, entity extraction, language operations, what is exactly that ML model or that pattern that you need to figure out. Then break the workflow into tasks, right? So now we have identified the workflow. Now what I'm saying is we should take the workflow and break it into tasks. And I'll show you this in an example over here. It makes it very clear. And then map the tasks to see if some manual process can solve it, traditional programming can solve it, or if an ML model is needed to solve that particular task. And then take an iterative approach, right? Maybe in phase one, you may just create a solution which simply augments the human. So this is, by the way, another common mistake I see customers making is they have this traditional solution in place for the last 10, 20, 30 years, which a human is actually solving it. And now they all of a sudden expect that we can completely replace that human. It usually doesn't work that way. It shouldn't work that way. The first phase of that solution should be providing the human with a tool, an AI-enabled tool, that can simply augment them or make them more efficient or make them more productive. And then you can iterate till full automation is achieved. And then, of course, always create meta cases and use cases that you can apply to other things in your industry, right? So that's sort of kind of the general workflow, the implementation design should look like for most AI problems. Now, having said that, this is basically just kind of different way of saying how you look at it, right? So analyze workflow for tasks. Workflow consists of discrete tasks. Apply the AI feasibility test to each task. In other words, now that you have picked a task, see if it's like a 1 second or less human observation, if it's a data prediction problem or a clustering problem. Never try to automate the entire workflow. Automate task by task and then iterate, and combination of AI and rules-based software to really solve the entire workflow problem. This is what it looks like, right? So this is a workflow example over here. And this is a radiology workflow. So what does a radiologist do? Kind of simplified, right? Obviously. Well, a radiologist may come in and he or she may review the patient notes and draw some conclusions. Then that person may go and discuss with the patient and evaluate some symptoms. Then that person may study the X-ray and come up with a conclusion or a diagnosis based on that X-ray. Evaluate any other medical reports that need to be, and then come up with a final diagnosis, right? So this is what I call as a workflow. And each of these boxes on the screen represents a task within a workflow. So now that you have identified the workflow and broken it down into tasks, to me, looking at an X-ray image and coming up with a diagnosis is probably the best case for AI over here. Because if you think of it, looking at an X-ray image is essentially like a pattern recognition problem, right? You provide a training model, you provide an AI model with like tens of thousands of those X-rays, and it will start becoming very accurate. In fact, in some of these types of radiology applications, now they are saying that it is at human parity for sure, and sometimes even at beyond human parity. Some companies have run some benchmarks and tests, and they have found that if you show a particular X-ray to a doctor, and again, I'm talking about complicated X-rays, right? Not the obvious cases, the edge cases, basically. If you show that to a doctor on a Monday morning, he may come up with a particular recommendation. And if you show it to another doctor on Wednesday afternoon for an edge case, for a complicated case, she may come up with another recommendation. Or in fact, that same person later in the week at a later point in time may actually have a different opinion about it. So a computer is never going to do that, obviously, right? it's going to be always consistent. So that's very interesting to note. So again, this is a workflow. These are the discrete tasks. And potentially this task is a good candidate for enabling AI. So now all you have done is you have now enabled the radiologist, made him or her more productive by giving an AI tool, which does this extra recognition and determination very quickly, as opposed to taking this entire thing and coming up with a solution. That's not going to work. Another example over here, this is an HR recruiting workflow where, again, this is a workflow and there are multiple tasks in it, right? So this is, if you have been through an interview lately, right? Review, and if you're a recruiter, so a recruiter will come in and review all resumes of applicants and try to do keyword matches. So if an IT manager has put out a job request, say they need a Azure person with Azure Data Factory experience. So those are some of the keywords, right? So that's what a recruiter does because he or she may not be technical. So they kind of look at the high level keywords. Then they shortlist and interview candidates. They schedule the next round, potentially evaluate our feedback, recommend the top candidate, and make an offer. Now, in this case, this keyword match of figuring out what the job description is and doing an intelligent search, right? Not just a search, but doing an intelligent search on your pool of resumes is something I see is absolutely a good candidate for automation from AI. So this is another example of where you can take a workflow and basically break it down into discrete tasks. All right, let's talk a little bit about data preparation, right? So as I said, most problems are solved by supervised learning. Supervised learning is all about training data. You have to invest heavily in getting data. Do not forget this point. This is like, super important, super critical. If you do not have enough training data, your models are not going to be that accurate and may not even be useful. You may want to leverage data augmentation techniques, some way to generate reasonable data. There's a technique called transfer learning, which is in research. So I'm not going to focus on that. But data preparation phase is absolutely important. Now, if you do not have sufficient data, what are some of the tricks that you can leverage to handle a case where you don't have sufficient data? And that, by the way, does happen. Data is the number one problem we see when we do AI projects. And the data preparation phase, whatever, and everything that it entails, takes a long amount of time. About 70 to 80% of the project time is basically spent on that. So be very aware of that. Now, if you do have lack of data, what are some of the tricks, right? So, and again, I want to be very careful when I say this. It's going to depend on your particular situation. It may depend on the specific model you're using, on your specific use case. So these are not generalizations. These are just thoughts that you want to probably keep at the back of your mind and then make a decision if it's applicable or not. In some of the situations that I've been, we have tried to see that if we can use business rules, which is essentially just standard software programming, to kind of narrow down the model parameters and kind of reduce the number of parameters that we have to use to make a prediction. So limit features is what it's called, and come up with a simple model. And again, be careful. This may work, may not work. Then there is a concept of post-processing, right? So let's just say I am coming up with an object recognition model, a computer vision model. And what I'm trying to do is I have, say, printed forms in front of me. I'm working for a company which has had documents, PDF documents, where people have written some stuff on it. Now they want to run computer vision on it and unlock all that information. So in that case, what happens is if I do not have sufficient training data, say I'm asking for 5,000 forms and the company can only give me 25, then we can use some techniques where we can build the model to the best of our abilities, and the model spits out its results, and then we can do post-processing on those results, right? That's what I mean by post-processing. So for example, if there's a particular field in the form, we can create a domain list of values and see what the model has kind of spit out and make a reasonable guess using a rules-based engine. So this is a real situation I'm facing with one of my customers right now, is they have a form and some people handwritten may write okay, But the way people write K, sometimes the model thinks it's an R. But I know in that field, OR is not possible. So I may sort of kind of default it or modify the output in my JSON key value pair to a K, right? So that's what's called as post processing. Levelstein distance. This is a concept where in the minimum number of characters, the ability to change a word from one to the other, right? Like for example, say the word simple, simple and sample. So the Levenstein distance there is 1 because with just flipping one character from I to A, I can change simple to sample. So those types of techniques, right? And again, be very careful with this. But these are the sorts of things that I encourage people to think when we do not have sufficient training data, which is a real problem in the industry. Okay, unified data warehouse. This is another very, very key component. And the interesting thing with the data warehouse is it has to store your structured, unstructured stuff. It can be a data lake. We need to do a multi-feature analysis. The more features, the better from a prediction perspective. So we need all this, plus internal and external data sources. So this is another key component for doing enterprise-wide AI. Okay, so the way I recommend building out this rhythm between an enterprise data warehouse and different use cases is something like this, right? If I go tell a customer that I'm going to build this intelligent data platform for you first, and that's about a year and a half project. And then after that, you'll see my first AI use case come out. That usually doesn't go well. So what we recommend is let's evaluate a few business use cases. Let's figure out maybe 1 or 2, what we call as the Lighthouse AI project. Let's just go implement those quickly, show quick ROI. While we are doing that, in parallel, let's assess and build an intelligent data platform, right? So then we start building the data platform in a very agile fashion, and then we deliver more AI use cases. And then we keep building, adding more sort of kind of subject areas to the data platform, basically. Think of it that way. We add more subject areas, solve more AI use cases. And this becomes a very agile, iterative cycle. And then we can go ahead and establish, ML ops and a COE and all that kind of stuff. So this is sort of kind of what we recommend. So what this does is you show quick results. It's iterative. You're not asking the business to wait for about a year and a half till you're done with this, and you can have some impact fairly quickly in the life cycle. A quick note on an AI team structure. This is kind of what is the most efficient AI team structure we are seeing today. The AI COE team with essentially connections across all the business units. So a common structure which can share best practices, repeatable patterns, use cases, all that kind of stuff, cross-pollinate ideas across different teams, right? So that's kind of where, because of the nature of the technology and the expertise needed, a centralized AI team. And again, it's not under IT. It's basically a team of its own, directly reporting into either the CIO or the CEO. Okay, let's talk a little bit about AI on Azure. Any questions, Weber, so far?
No, but I have a question to you. Question for you. Can
Sure.
I? Yeah, so
Yeah, go ahead.
what's the difference between artificial intelligence and machine learning? Because what I'm saying is we are training a model, and what you are showing, right? Is it
Yep.
similar to training a model, MI model, a machine learning model, sorry?
Yes. So, and I'm glad you asked that. Maybe I should insert a slide in my next iteration of this. Artificial intelligence, think of it as the highest level umbrella, or almost like a generic term, basically, right? So AI is more as the subject area terminology. Within AI, there is a field called ML, which is machine learning, which is all these different models. And within machine learning, there is yet another field called as deep learning. So there's a difference between machine learning and deep learning, right? So machine learning is a little bit at a higher level where you have some basic models using basic algorithms such as, say, linear regression, by which you can solve these problems. And then deep learning is where you have an example would be like a neural net, where you have multiple of those algorithms stitched together almost in a network. So that's kind of the hierarchy, basically. So AI, think of AI as the high level umbrella. Then there's machine learning. There's deep learning, and then there's also, data science and data engineering and all those fields. So they're all sort of kind of related, with some differences, basically. Hope that answers that.
Thank you.
Okay, now let's talk, now that we have talked a framework and a methodology, let's talk some very practical things on what's going on Azure today. I think mostly we all of us work on Azure. So the way Microsoft is taking an approach with AI, and I really like some of the things they're doing. The very first thing they're doing is they are completely embracing open source types of frameworks, such as Keras, PyTorch, TensorFlow, and a few others, right? These are what we call as the deep learning frameworks or the deep learning libraries. So when I say like a scikit-learn library, these are basically libraries of ML models or algorithms that you can leverage, and you can call with some modifications, some customization, and kind of start building your AI model based on that. And that is really wonderful. And in fact, if they had not done that, they would be nowhere close in the race, because it's simply impossible now for one company to do all these development. It's really an open source world. The collaboration in the open source world in this area is just simply unbelievable, right? So that's one thing to kind of keep in mind. Of course, they're providing a whole lot of management tools from an AI perspective, Jupyter Notebooks and Azure ML Workbench and Azure ML Studio, Azure ML Services, obviously Visual Studio tools and all that kind of stuff. Sorry, I started from the right-hand side. On the left-hand side, they have these services. And again, I'm going to talk a little bit about what is cognitive services over here shortly. So they have cognitive services, which is, think of it as a API you can simply call, right? So one of the problems we are working on from a cognitive services perspective is a speech to text. So I can simply call the speech to text API, pass my speech files, and it will spit out my text files for it. The advantage for that is I don't have to build a model. Technically, I don't even need a data scientist at that point in time. Any programmer can basically do that. It's just like an API call. So that's what is called as cognitive services. Then they have the bot framework for creating conversational AI experiences, such as chatbots and things of that nature. And then, of course, there's Azure Machine Learning. Where Azure Machine Learning comes in is you can use combination of Azure Machine Learning and, say, one of the deep learning frameworks to come up with custom models. If you have to really design things from scratch, you can absolutely do that. Now, let me give you a very specific example of that we are using as we speak. Microsoft has a tool called as the Forms Recognizer. What a Forms Recognizer is basically, it's again an AI tool where you can use it to train it to look at PDF forms, let's just say. And it can then figure out what's going on in the form. So it can basically look at the form just like you and I will, and it can come up with key value pairs that, oh, there is a work order number. What's the work order number? It can extract that. Oh, there is a date. So it can extract the date and the value. Or there is a measurement of some sort, whatever it is, right? So kind of going back to the example, right? So basically, that's the Forms Recognizer. Now, in addition to the Forms Recognizer, what we have done, where the Forms Recognizer is falling short, is we have built some custom models to recognize some very specific things on the form, such as handwritten text, which perhaps the Form Recognizer is not falling short. At that point in time, we used Azure Machine Learning Services and used a custom vision model from these libraries to come up with an effective solution. So you can basically piece all those things together. And then, of course, you're probably familiar with all the Azure infrastructure, right? Cosmos DB, Databricks, Data Lake, and the data science virtual machine, so on and so forth, all the edge computing devices and all that, right? So this is kind of the Azure AI platform. It's pretty powerful. It's pretty capable. And of course, it keeps changing and reinventing every few months. So they keep adding new capabilities every few months. But this is kind of the key platform that you would use to do your AI projects. Now, I was mentioning earlier about cognitive services, right? So there's different types of cognitive services available. At a high level, what cognitive services is basically AI in a box. Just think of it that way. It's AI in a box. You don't have to do any modeling. You don't have to be a data scientist. If you want to get started with a project, you can simply call the Cognitive Services API, depending on what your project is. And there you go. You may have a solution put together very, very quickly. And as you can see on the slide, there are cognitive services in a variety of different areas. And Microsoft's goal is to keep adding to these, right? So there's vision. If you want to come up with a computer vision model, you can use this. And some of these are also trainable and customizable. So you can train it with your own data and customize it to your own needs. And again, if none of this works, you always have the platform to write your own AI model, basically. I definitely encourage you to go on the documentation and look up all the different capabilities of this. But this is something to absolutely keep at the back of your mind. And this is the direction Microsoft is taking, but at the same time also giving you an open platform to do your own modeling and stuff. Okay, so you probably have seen this architecture before. So this is sort of like a architecture I want to show, which involves multiple components, all the way from the data feeds and the data sources to different ways to do data ingestion. Azure Event Hub, Azure IoT Hub, potentially Azure Data Factory, machine learning flows to data storage. Data storage can happen in Azure Data Warehouse, which is now called Synapse, or it can happen, in a Azure Data Lake. Then there is compute and analytics over here with the OLAP models and the advanced machine learning models and whatnot. And then you can basically tap into Cognitive Services API, or you can build your own machine learning models, and then tools to consume those models or the output of those models through Power BI and whatnot. So this is a very much of an Azure-based architecture using different components. Now, again, one thing I do want to emphasize is you don't need to build this entire architecture out on day one. You can start with very simple components in each of these areas if needed, or some of these areas, and can start coming up with some very good projects, and you can incrementally add and build to this. All right, having said that, wanted to show you guys an actual architecture that we have implemented. It's called our Factory of the Future offering. And what the Factory of the Future offering is basically, say you're a manufacturing unit and you have some sort of factories with all these different equipment, and the equipment have IoT sensors and whatnot. So we are collecting data from those different equipment, different pieces of machinery, running AI models on it to figure out predictive maintenance. So we can make a recommendation that you need to take this machine down, do some maintenance on it, because we suspect that it is going to break soon. Think of it, how powerful that is, right? If I can predict what is going to break before it breaks and you can do something about it, that's going to save you tons of time and money. So that's an example of predictive maintenance. Another example is anomaly detection, that we are looking at the streaming data and then we can identify that, wow, this stream seems to be out of place. There's an anomaly there. So this is an architecture that we have implemented on Azure, which consists of on-prem sources, all the different corporate data. There is Active Directory authentication, IoT Hub and Stream Analytics, Cosmos DB for storage. And then we have implemented some cognitive services as well, probably machine deep learning models over here, and then some way to kind of output it basically. And again, with any ML model you create, you can basically tap into the API and it becomes a callable API. This is a virtual agent architecture that we have implemented using the Microsoft bot framework. So most companies have virtual agents these days, right? And it's pretty simple to implement that. We have leveraged what is called as the bot framework from Azure. to do that. And that's kind of what the architecture looks like, right? So this is where all the different channels are from the interaction perspective. And we are leveraging bot framework. And then we are also leveraging different cognitive services APIs, such as, a speech API or a language API, things of that nature. And then potentially can tap into Active Directory and some backend systems. Okay, this is an actual screenshot I took, or somebody took for me, I guess, very, very recently. And what this is I wanted to show a workflow over here in Azure Data Factory that we have created to solve a real problem. So what we are doing over here is we are using the Microsoft, the Forms Recognizer tool, which is basically their AI API to do forms recognition, right? The example I gave earlier, that you have PDF form and you want to recognize different entities in the form. So this is where we have tapped into that. And we have also written our own custom models to do some complex things. So, and again, we are using Databricks, as you can see over here, to copy that. So this is an example of a real workflow that we just very recently developed. In fact, this was done literally just a couple of days ago, to do forms recognition using ADF on Azure, using the Forms Recognizer tool in combination with some custom models we developed to recognize entities that Forms Recognizer is not able to do, right? So that's an example of that. Okay, moving along, I'm going to jump into some case studies that I want to discuss with you guys before we close out. I know we are right about at 7 o'clock, so I'll only take maybe a few more minutes to do that, maybe 5 minutes or so. Any questions so far, Weber?
I think we are all good.
Okay, very good. Well, everybody likes to always see real life case studies, right? So this is an automated object detection application that we developed for a grocery store over here, right? So what they were trying to do is they were sending employees to grocery stores to verify that their products were occupying the amount of space on shelves that they were paying for. So somebody had to actually walk in a grocery store and actually visually observe if their products are there or not. And remember, I told that approximately that 1 second rule, that if you can observe something in a second, most likely the computer should be able to figure it out, what you're trying to do. So obviously this was very labor intensive. A lot of people, a lot of grocery stores, a lot of shelves, a lot of time, effort, labor. So our clients' products and then compare it to the space on the shelf. So we would identify that there are so many bottles of Smuckers, whatever this is, and figure out how much space is there, and then make a determination if that's the right usage of that space or not. So pretty cool object detection model. This is the document entity extraction I keep talking about, where again, if you have forms and you need to unlock the data sitting in those forms. I mean, imagine, right? Every company has forms in HR, in manufacturing, in marketing, in finance, whatnot, where there's data sitting over there and you're not able to unlock it. And you can use document entity extraction to look at those forms, extract those key value pairs, and go store it in a database. So that's pretty cool. Supply chain analytics. So this is a very, very common problem where one of our customers was struggling with on-time delivery of cars to end dealers. And they had to figure out the estimated time of arrival, estimated departure, so on and so forth. So we looked at all the different data sources, including transit, inventory, estimated shipping dates, 100 plus entities, and came up with a multi-class decision jungle model to predict ship dates. So this had a huge impact, right? The model was implemented in Azure, and we were 3 times more accurate than whatever they had in place, reducing the average deviation from shipment date from 7 days to 3.5 days. So that can make a real business impact. AI-driven inventory tracking. So this is very similar to the example of the grocery store. Now, this is a medical lab type thing, probably very relevant in today's situation we are in. But again, this was a custom object detection model, and we had object recognition as well as face detection. In this, it was deployed to edge computing nodes with connected cameras and all that kind of stuff. So we managed this poor inventory issue for this hospital, which saved them, millions of dollars per year. This is a vision-based AI determination, and what this is there's a water quality issue over here, and this company had a test strip which they would dip in the water, and the strip would change the color. And there were some nuances to that, so they had to ship that. Customers had to actually ship that test strip back to their labs, where they would analyze and make a determination. Now what we did is we developed this AI application where they can simply take a picture of that test strip through their phones or handheld devices. And right there, we can make a determination of what is the water quality. So it was an intelligent identification, cropping, quality control type of application. It was a bacterial testing strip that we developed from an application. Okay, this is predictive maintenance. This is a company called Baxi. I think it is based out of Europe, I believe, in the UK. And this was very, very interesting. So we were able to forecast with a 98% accuracy on where we are going to get maintenance calls for these boilers. So the boilers kept failing, and they were not able to predict and come up with the right resource allocation to do the maintenance. So we used their internal data as well as we used external sources like weather data. And we came up with 450 machine learning models using Azure ML service to solve this problem. And the model predicts with a 98% accuracy. That's actually very, very good. If you can predict that accurately on where your service calls are going to come from, that's phenomenal, actually. Okay, this is an example of a virtual agent, right? Somebody brought up the topic of virtual agents earlier. We developed this using the Microsoft Bot Framework and Lewis. And this was implemented in their contact center. Now, if you look at the impact, 65% of user identification is done by digital agents. 900 calls per day are managed by the bots. This has resulted in savings of 60 human hours per day, leading to considerable increase in operational efficiencies. So really, the idea over here is rather than everybody calling into a call center and trying to, ask questions, let's just say it's insurance, trying to look up your insurance information or whatever, you simply give a bot on a website and you have a human-like dialogue with it and figure out a lot of the stuff that you need. Ultimately, you may have to transfer to an agent, but you can take care of a lot of initial calls. This one is, again, an example of predictive maintenance. This is a premium car brand company, very, very famous. And they were having some problems with their camshaft drive chains. Frequent failures with that, which led to, as you can imagine, if you have this expensive European car and it's failing, you're not going to be very happy about it. So we set up a big data platform to ingest, analyze, process data from these massive sensors, and then predict, essentially camshaft drive chains issues and potential issues with it. So again, this was very, very effective. And this is another example of predictive maintenance, where we are collecting and ingesting IoT and streaming data from over 10,000 wells across 700 facilities and fields and all that. So predictive and real-time event detection using Azure ML, ADF, pump failure type of things. And again, with all this IoT streaming data across all these different wells and facilities, We were able to come up with some good recommendations on, precursors to failures and optimize their maintenance scheduling and all that around well maintenance and repairs. All right, this is another virtual agent, intelligent bot type of example over here. This was an enterprise grade implementation we did where they can provide factory and knowledge workers with real-time contextual relevant information using an industrial conversation platform, right? So the key thing over here is this was customized to the industrial context because the terminology over there is different and they're trying to have a different type of interaction. So again, in an industrial type of setup, the client now has natural language driven troubleshooting and knowledge management capabilities. So it saved them tons of hours, right? So somebody would go near a piece of equipment, and by observing the equipment, the type it is, it could basically have a natural language conversation as to what the equipment is about, what is the maintenance procedure, maybe, what are the types of things they should look at, so on and so forth. All right, so having said that, that basically ends the presentation. I'm sorry I went about 10 or so minutes over. But any questions so far?
I don't see anything on the chat window, but people are free to unmute themselves and Sudhir is done with his presentation. And does anyone has any questions for Sudhir?
Hey, Sudhir, can you hear me?
Yes, sir, loud and clear.
All right. So I've been using machine learning in SQL Server 2017, and one of the features I've been using is the new stored procedure SP execute external that allows you to shell out to Python scripts. So when I've been talking about this to groups, I mentioned that this is really exciting stuff because it's enabling you to do in database analytics. So I've eliminated the cost and the security of moving the data out of my environment to do this type of analytics and then having to store it back in.
Right.
So the question I have though is, when I say this, I also say this is really exciting, and I expect Microsoft will be developing a lot more along this direction, in these in-database analytics tools. Where do you see a lot of the excitement or all the development at Microsoft in these types of tools? Like, is there a specific direction they're going with? I know they're open source, that's fine, but is there something specific, more specific, that you've heard in the grapevine?
Yeah. No, definitely. I can give you my perspective, and if Steve is still on the line, he can also give his kind of official opinion. But kind of working very closely with Microsoft, this is what I'll say. Well, let's kind of take a step back, right? So let's go back several years. So when the public cloud came around, AWS had a huge market share and a huge advantage over every other competitor, right? So basically they came up with this simple concept of what is called as an IaaS, infrastructure as a service. I'm talking like 10, 12 so years ago, right? And then everybody jumped on that, and then Microsoft was sort of kind of slow to catch up. Of course, it's catching up now very, very quickly. But the point I'm trying to make is AWS led with a simple concept in the cloud, and they got a lot of market share. Now the positioning of all three vendors, Azure, AWS, and Google, is that battle is over. Nobody's interested in that. That's a very much well-known commodity. The next frontier is AI. And every single of these vendors, AWS, Microsoft, and GCP, and potentially even IBM, though that doesn't get mentioned that much these days, they are all trying to put all their energy and effort into different types of AIs, right? So given that background, John, to specifically answer your question, I see three broad categories where Microsoft is making big AI investments. One is what they call as infusing their apps with AI. So say you buy the Dynamics solution from Microsoft. They are trying to put as many AI enabled features in it, like, so you have Dynamics and you're collecting customer data. It's a CRM solution you're implementing through Dynamics. You're collecting customer data. They are trying to come up with built-in AI features or algorithms which can then predict potentially, say, like customer churn or things like that, right? So infusing with AI apps, that's one area of investment they're doing. The other area of investment they are doing is basically just the overall broader AI platform. Like example of that is Azure ML services. So they are putting a lot of energy, research and effort into broadening that platform, right? So they're making tons of investment in the AI platform. And again, there's no such thing as an AI platform. What it really is a data platform. So they're making investments in Synapse, making investments with the Databricks partnership, so on and so forth. So that's the second category. The third category I see is the investment in cognitive services, where they want the ability to customers to develop custom models, write things from scratch, because sometimes that is necessary. But at the same time, they also want to make things as easy by providing these cognitive services APIs. So that's basically the third area. And the fourth area, so to say, is this whole notion of the Power Platform with low code, no code. So they are kind of infusing a lot of things from an AI perspective there as well. So they are really not holding back in any of those areas and making lots of investment in all of those areas, which kind of makes it very exciting and interesting. There's so much for us to learn, and things are going to change so fast. I mean, I worked for Microsoft for almost a decade and a half. Some of you probably know me or recognize me from my tenure there. And I was known as the SQL Server guy. Now, if you ask me a thing about SQL 2018, well, I just made the point. I don't even know what version of SQL we are at right now. I'm like totally disconnected from that world, because this world of AI is such a different world and such a constantly evolving world that it's really exciting. And there are so many things you can do in it. You can be a data scientist, you can be an ML engineer, you can be a data engineer, you can simply work on Databricks, you can be a Synapse expert. That ecosystem is big. And I'm just talking Azure over here, right? If you throw AWS on it and if you throw GCP on top of that, it's like a big world out there. So sorry, long answer for your question, but hope that addresses it. I don't know if Steve is still online. If Steve, if you want to make any more comments.
I think he is not on the call. He dropped off.
Okay. All right. Yeah. Understandable, I guess.
Oh, that was excellent. Thanks, Sudhir.
Yeah, sure.
Anyone else has any question?
Yes, Vaibhav. Hi, this is Akash.
Yeah, Akash, go ahead.
Hi. I have one question. I'm not sure if this was covered in the presentation. It was pretty exhaustive. Thanks, Sudhir. Any thoughts about AI on edge devices? It's something that is the next generation, I guess. Any thoughts or any work you have done with edge AI?
Yeah, so there's quite a bit of, and I'm glad you bring that point. I mean, that's another dimension, in fact, and in fact, another field in itself, where lots of advances are being made, through Azure and of course the other vendors as well. And Microsoft has this set of solutions called the IoT Edge solution and the IoT platform, basically, where they are building all these frameworks and different types of capabilities and whatnot, purely from an IoT edge perspective. And the concept there is actually pretty interesting, right? I mean, the original concept with AI was that you're going to need, a huge amount of computing power and storage and all that to train a model, the learning part of it and everything, and then the deployment of it. Now they're saying that, sure, you can always do that, and there are going to be some use cases where you probably need that. But then there's also going to be a situation where you may need to deploy that model on a much, much smaller device. I think an Apple Watch is a perfect example of that, right? I'm not an Apple Watch user, but I've heard that an Apple Watch can basically tap into your pulse or some rhythm of your heart, and it can predict if you're having some sort of cardiac episode. So that's a perfect example of an edge device having intelligence built in, right? So that's kind of where a lot of the industry is going as well, is trying to push these models down to edge devices and do AI on the edge. So hope that answers the question.
Sure. Yeah. Thanks, Sudhir.
Anyone else?
I just recently saw that, Sudhir, with IoT thermometers during this virus outbreak, and they were showing heat maps, like areas in Florida where the temperatures that they're collecting from these IoT devices, and pretty interesting. Brings up some privacy concerns, but interesting data nonetheless.
Oh yeah, absolutely. And another kind of almost funny example is one of our AI teams in Poland. They actually have come up working with a manufacturer with IoT-enabled diapers. So if the diaper gets wet before the kid starts crying, you will get an alert on your smartphone. So the extent they can take this technology is just unbelievable.
Now that sounds like something you want to be able to predict.
Yeah, that would be interesting to write an algorithm on that. Yes, absolutely. All right. Well, any other questions, Sueva?
I don't think so. I think we are good. And I know Sudhir is on LinkedIn. And Sudhir, if you want to share a contact, if someone wants to reach out, feel free to share it with people who are on this meeting.
Yeah.
Otherwise, you can send me a note with the question. If you get any question later, I can pass it on to Sudhir to get an answer on.
Yeah, no, absolutely, folks. And again, really, really want to thank Vaibhav and our sponsors today. I enjoy and I really love doing this. I wish we would have been able to do this face to face, but given the current situation, I'm glad we at least, let life go on and met virtually, and we're able to do this. So thank you so much for the time, and I hope you got some interesting things. And again, as Vaibhav said, if you have any questions, just ping me on LinkedIn. I think that's probably the best way to kind of reach me on a public setting. But absolutely happy to work with you guys. So thank you so much.